A probability distribution describes in some way how probabilities are distributed over values of a random variable. Now, there are a couple of different ways of showing a discrete probability distribution, that is, a probability distribution of a discrete random variable. One way is by creating a table. One way is of making a graph. Another way is to use a formula. These are all valid ways of showing a probability distribution. Now, the probability distribution of a discrete random variable is defined by the probability function. Written f of x. Now, the probability function provides the probability for each value of a discrete random variable. Now, it's important to note that probability functions are only for discrete random variables, not for the other type of random variables, which are continuous random variables. Now, there are two requirements for our probability function. The first requirement is that each f of x is greater than or equal to 0, and the second requirement is that the sum of f of x is equal to 1. Now, these are almost the same exact requirements as probability in general, which makes sense because the probability function just gives you the probability. Now, let's take a look at an example of a probability distribution given by a table. So we have two columns here in our table. We have x, which is the values of the random variable, and we have f of x, which are the probabilities associated with x. So the values that the random variable can take are 20, 25, 30, and 35. The corresponding probabilities are 0.20, 0.15, 0.25, and 0.40. Now let's start by checking to see if this probability distribution is valid. So in order for this probability distribution to be valid, it has to meet the two requirements for a probability function. So looking at the different f of x, we see that each f of x is greater than 0. So this means that the first requirement is satisfied. Now let's look at the second requirement. The sum of f of x is equal to 0.20 plus 0.15 plus 0.25 plus 0.4, which is equal to 1. So the second requirement is satisfied as well, so both requirements are satisfied. Now let's calculate some probabilities using this table. First, let's calculate the probability that our random variable x will be equal to 30. Now this is just going to be given by the probability function when x is equal to 30, which is f of 30, which is equal to 0.25. Now let's calculate the probability that x will be less than or equal to 25. Now there are two values of the random variable that satisfy x less than or equal to 25, and those are 20 and 25. So this is going to be equal to the probability that x equals 20 plus the probability that x is equal to 25. So 0.2 plus 0.15, which is equal to 0.35. So the probability that x will be less than or equal to 25 is 0.35. Now let's calculate the probability that x will be greater than 30. Now there's only one value of the random variable that satisfies x greater than 30, and that is 35. So this is just going to be equal to the probability that x is equal to 35, which is f of 35, which is equal to 0.40. So the probability that x is greater than 30 is equal to 0.40.